All right, welcome to the Explainer. So, you're going for your certified cloud security professional, sir, right? Then having a rock-solid foundation isn't just important, it's everything. So today, that's exactly what we're going to build. We're diving deep into the absolute core of CCSP Domain 1.
So here's the game plan. It's a pretty straightforward four-parter. We'll kick things off with the basics, the real ground-level stuff. Then we'll get into the blueprints for building things out. After that, we'll talk about the actual defenses, the shields and walls. And we'll wrap up by looking at the big picture, strategy, and who you're going to partner with.
All right, let's get right into it. Think about it. Before you can even think about building a fortress, you've got to understand the terrain, right? The very ground you're building on. So that's what this first part is all about, the fundamental rules and the key building blocks of the cloud itself.
Okay, so we kind of have to start here with the official NIST definition. And the key thing to get is that the cloud isn't really a thing. It's a model. It's way more like a utility, like the power grid for your house, but instead of electricity, it's delivering computing resources. And just like the grid, it's on demand, you can access it from just about anywhere, and it's all coming from this big shared pool.
So check this out. These 5 things are what make the cloud, the cloud. But here's the kicker, and this is super important. Every single one of them is a double-edged sword. On-demand self-service? Awesome for speed, but man, you better have your security automated. Resource pooling? It's cheap and efficient, but now you've got to worry about keeping your stuff completely separate from your neighbors. And that right there, that's the central challenge of cloud security.
Okay, so we've surveyed the land. Now it's time to pull out the blueprints. We're talking about the big architectural choices here. These are the decisions that are going to dictate the entire shape of your fortress, what kind of walls you can build, where the gates are going to go. Things like which services you'll use and where you'll actually deploy them.
Okay, listen. If there is one single concept you take away from this whole explainer, please let it be this one, the shared responsibility model. It is the absolute fundamental contract of cloud security. Think of it like this. Your cloud provider, they're responsible for security of the cloud. They build the fortress walls, the physical gates, the foundation. But you are responsible for security in the cloud. Everything you put inside those walls, your data, your apps, and most importantly, who has the keys, that's all on you.
And this chart? It lays it all out perfectly. You can see exactly how much responsibility you're taking on. If you go with IaaS, infrastructure as a service, well, you're basically renting the hardware and virtualization. The operating system, the apps, the data, that's all your problem. Move over to PaaS, platform as a service, and the provider handles the OS for you. A little easier, right? But you're still on the hook for your application. And then you get to SaaS, software as a service, and all you're really worrying about is your data and who can access it. See how that works? Your choice here completely changes your security job.
Right, so the next huge decision is where are you going to build this thing? You could go with a public cloud, huge scale, super flexible, but you share in the neighborhood with, everyone. Or you could build a private cloud. Total control, it's all yours. But guess what? You're also responsible for everything. And then there's hybrid, which sounds like the best of both worlds, and it can be, but man, does it make security complex. Now you're juggling those shared responsibilities across completely different worlds with different rulebooks. Now, one thing to remember is that your blueprints aren't being drawn on a blank, static map. The world is changing, and new technologies are constantly redrawing the battlefield. Take the Internet of Things, or IoT. This isn't just some buzzword. We're talking about a crazy expansion of your attack surface. Every single one of those little sensors, the smart devices that phone home to your cloud, each one is a potential new unlocked backdoor into your fortress. And then, if we look even further down the road, you've got this lurking giant, quantum computing. Now, is it going to break your encryption tomorrow? No. But the potential is there for it to completely shatter the cryptography we rely on today. And what that means is that we have to start thinking about a post-quantum world, like right now. The shields we're forging today have to be designed in a way that we can swap them out for something new when that future threat becomes a reality.
Okay, Section 3. Let's talk about our active defenses.
The blueprints are done, the foundation is poured, now it's time to actually post the guards at the gate, raise the shields, and patrol the walls. We're getting into the nitty-gritty security tools and concepts that you are going to be using day in and day out.
When it comes to defense, it all starts with identity. You absolutely have to know who and what is trying to get in, and what they're allowed to do once they're there. And this isn't just about your human users. You've got to lock down those super powerful admin accounts, and, just as important, the automated service accounts that run in the background. And the whole time you're following that one golden rule, the principle of least privilege. Don't give anyone or anything a single permission they don't absolutely need to do their job.
So what happens when you need to get rid of data for good? Hitting delete just doesn't cut it in the cloud. The real pro move is something called cryptographic erase. It's actually a pretty clever trick. Instead of trying to find and shred every last bit of the data itself, which is almost impossible in a distributed cloud environment, you just destroy the encryption key. Poof! The key is gone, and the data instantly becomes permanently unreadable, useless gibberish.
All right, let's talk virtualization, because it's got layers, and you have to know which layer is your responsibility. So at the bottom, you have the hypervisor. That's the core engine that runs all the virtual machines. Securing that, that's the cloud provider's job. And thank goodness, because if a hypervisor gets compromised, it's game over for everyone on it. Now your job is often one level up, securing the containers that are running your apps. And that means making sure the images you're building from are clean, and that their runtime environment is totally locked down.
Okay, for our final section, let's pull the camera way back. We're zooming out from the individual tools and tactics and heading up to the strategic command center. This is the big picture stuff. We're not talking about firewalls here. We're talking about how you bake security into your DNA, how you justify your entire strategy, and how you pick the right allies to go into battle with.
You know, a truly secure architecture isn't just a snapshot in time. It's a life cycle. It follows your data from the moment it's born to the moment it dies, from cradle to grave. And at every single one of these stages, create, store, use, share, archive, destroy, you have to be asking, what are the risks here, and what's the right control for this stage? Whether it's encryption, or access control, or data loss prevention, you need a plan for the entire journey.
This right here, this quote captures the absolute soul of modern security. You just can't bolt on security at the end anymore. It doesn't work. It's like building a whole castle and then trying to figure out where the moat should go. It's got to be designed in from the very beginning. And in the cloud, where things move so fast, that means DevSecOps. It means security is part of the conversation on day one of any new project.
So let's be real. How do you get the money to build this awesome secure fortress? You have to speak the language of business, and that language is return on investment, or ROI. The tool for this is the Business Impact Analysis, the BIA. The BIA is your secret weapon. It's how you go to the people with the checkbooks and say, look, if we get hit by this attack, it's going to cost us this much money. But if we spend this smaller amount on these security controls, we can prevent that. You're translating technical risk into dollars and cents, and that's how you justify your budget.
Look, you're not going to get a hard hat and a tour of your provider's data center. It's just not going to happen. So how do you trust them? You look at their report cards. And that's exactly what these certifications are. Things like ISO 2717 or a SOC 2 report, they're not just fancy logos. They are independent third-party proof that the provider is meeting incredibly strict standards for how they handle security, how they protect your data, and even how they implement their crypto.
And that really brings us to the final and maybe most important question. We've gone over all these foundational concepts, and you absolutely need to know them for the CSCP. They're the bedrock. But the ground is always shifting under our feet. So the real question I want to leave you with is this. As the entire industry moves towards new ideas like zero trust, this model where you basically trust nothing by default, which of these fundamentals we talked about become even more critical, and which ones might become, well, less important? Thinking about that, that's what takes you from just passing an exam to being a real cloud security pro.